Now let us discuss about the bond-rate MAC50 substitute formulation science for our surface condition. Let us discuss about the uh, original product, that is a bond-rate MAC50. Then let me explain about the key function rules and mechanism so that we can very well understand about the chemistry behind that. Then I'll be explaining about the substitute equivalent requirements also. Then let us have some equivalent formulation approach, and you have to try it in the lab scale only. Now let us proceed with the original product, that is Bondrite MAC50. Here, let me discuss about the role, function, and the surfaces treated with this Bondrite MAC50. When we consider the role, that is, it has got the powdered, that is, structure. So this powdered surface conditioning agent acts as a very good activator for phosphating. It is used prior to phosphating. Then let us discuss about the function. Actually, this bondrite MAC50 promotes uniform, fine crystalline phosphate coatings. It also promotes dense and uniform structure. Then let me discuss what are all the types of surfaces treated with this bondrite MAC. That is, it is applicable on iron, steel, aluminum, and also zinc. Now, let me explain about the key functional roles and mechanism. So here, actually, it provides nucleation sites. Let me explain about the chemistry examples, compatibility, then conditioner requirements, and pH control also. So at the outset, I'll explain the provision of nucleosides, how it is happening. So here, the it supplies this MAC50 supplies metal cations or colloids. Actually, this is commonly titanium, zinc, or any other divalent or trivalent metal only. So it adsorbs on surface, particularly of any substrate surface, and it accelerates the conversion reaction also. Let me explain about the chemistry examples here. For instance, what does it consist? What is the composition of this bondrite AC50? The major ingredient is the suspensions of insoluble metal phosphate. That is Zn3PO4 twice as microparticles. And it has got some salts, preferably alkaline. Of course, this is a weak nature, probably from ammonium. And then it has got some microparticulate oxides. So that is called silica or titanium dioxide also. Then let me explain the compatibility aspects about this bondrite AC50. It must not interfere with the phosphate bond. So that is one of the essential expectations or requirements from this surface conditioning, because it has to condition the surface, but it should not interfere the phosphate bond. Not only that, the carryover should not spoil pH or ionic balance. So it must act like a buffer. And then the conditioner requirements. It has got very good stability. Actually, this is a good dispersion stability, I must say. It's a colloidal dispersion. And it should be tolerant to hardness ions also. Hardness ion means suppose if if the water contains any salts, it should be capable of tolerating all those things. Not only that, it should be stable in pH. Then, when we consider the pH control, That is, it is mildly acidic to neutral or mildly alkaline range. Normally, the pH lies between 4 and 9. Now, let us think of the substitute equivalent requirements. So here, that is, we have got the source of nucleating metal species like titanium or zinc. So that is one of the very essential ingredients. Then stability in aqueous solution or suspension. So that is also a must. That is the required phenomena for surface conditioner. And then the compatibility aspect. That is, it should have low interference with the phosphating path. Not like that, it should have proper pH behavior and it should be capable of buffering. That is, it should arrest the change in pH. And then let us try to have some formula based on this. The main ingredients and purpose we will discuss. Then, what is the procedure sketch? So, that is the next aspect I will be explaining. Then, we need some optimization also. Let me take up these ingredients and what are the function rules also. See, that is, it can be the metal phosphate, that is Zn3 PO4 twice particles, and alkali. The alkali is generally sodium phosphate, dodecahydrate. It is very particular, so you should have 12 water molecules. Then the one of the essential ingredients are that is microparticulate. When I say microparticulate means the particle size should be in microns. So you should have some oxide stabilizers. So the oxides can be zirconium oxide, titanium oxide, or silicon oxide. Then you should have some surfactant, and that is the anionic or anionic dispersion. Then the water, and there must be some pH adjusting agent, like with respect to acid or base. Now, that is what is the role of this metal phosphate that we will discuss. The main role is to provide nucleating metal phosphate species, and usually the range can be 1 gram to 5 gram per liter. Then sodium phosphate. So its role is to act as a buffer, and it should have ionic strength, and it should solubilize species. Then the range can be to 10 gram per liter. And then you have that is zirconium oxide or titanium oxide or silicon oxide. So, as I already told you, it is a microparticulate one, that is, it should be of micron size, and its role is to stabilize the dispersion so that it will prevent any agglomeration also. And the content should be, that is, the quantity should be as low as 0.0012 5 parts per million. I will explain, and in fact, I will share one important video regarding the concentration where I have talked about the parts per million as one of the concentration expressions. And then surfactant, or that is dispersant, preferably non-ionic or anionic, and its role is to improve wetting and dispersion stability. So, as usual, the amount may be 0.012 to 0.1 percentage. Then we should have water, and here the pH adjustment is required. So bring the solution to the desired pH. So normally it is between 5 and 8. So we can definitely make out this surface conditioner equivalent to bond rate MAC50, and it needs certain practice also, and you need some sophisticated material. We'll try to get it as early as possible. Thank you.